Today we're going to talk about our Haas mini mill setup. We're going to start that by talking about our power up procedure. On the control, we're going to locate our power on button and we're going to go ahead and press it. From here it'll take 1 to 2 minutes for the machine to wake up. Now that the machine's powered up, we're going to go ahead and follow the prompts on the screen to finish its power up procedure. On the screen we have cycle door, so we'll go ahead and cycle the door. We have turn off emergency stop, we'll make sure that's turned off. And then we'll press power up. And that's this blue button down here on the control. Now the power up procedure is going to fire the hydraulics as well as start the home out procedure on the machine. Now that the power up procedure is finished, we can go ahead and hit handle jog or cycle start to exit the Haas startup page. Now we're into the main screen of the machine. From here we can access things like our editing tab. We can go into memory where we load programs. We can go into MDI, which is manual data input. We can go into handle jog, which is what we'll talk about first, which is manual movement of the machine. And then I need to select an axis of motion, so I'm going to select my x-axis. And then I need to select a speed to move in. So I have tenths, thousandths, 10,000ths, and 100,000ths buttons. We'll go ahead and select our tenths button right here. Verify that we are in our x-axis. The axis of travel will be highlighted in yellow here at the bottom of the machine. Now to move the machine manually, I have a handle jog wheel here. Now, for movement in positive and negative directions, clockwise is always positive movement. Counterclockwise is always negative movement. To demonstrate that, I'll go ahead and I'll select my x-axis and my 10,000ths click button. That means per every click of this dial, it is moving 10,000ths of an inch. And when I go positive, clockwise, we can see we're moving towards the positive side of our table. And if I go ahead and rotate to the negative direction, we move to the negative direction of our table. If I go ahead and select my y-axis here and verify that it is highlighted, I can move it in the positive direction and see that we're moving towards the top side of this table. If I move towards the negative, we move towards the negative side of the table. Now when I select my z-axis, I verify it's highlighted. Positive is always going to lift the Z away from the table or your workpiece. Positive. Now if I move it counterclockwise, it's always going to be negative, towards the workpiece, towards the table. Be careful when moving tools away from parts of the table to always go positive. You do not want to run into the part. Now that we've covered the basics of handle jog, we're going to go ahead and talk about how to load a tool into the machine and set the tool up. To load the tool, I'm going to select my MDI button here, manual data input. And that's going to load this screen. Now if there's a code left over in this MDI box, this white box, I'm going to go ahead and hit this erase program tab, and that's going to clear the MDI box out. Now I need to grab my tool that I'd like to load in the machine, and we're going to start with tool 2 and go to 3 and 4. So to grab tool 2, I'm going to hit T2, M6 for tool change, and that's going to type in down here in the bottom left-hand corner of the screen. I verify what I typed in is correct, and then I go ahead and hit enter. When I hit enter, it's going to deposit that into the MDI box. Now from there, I can shut my door, and I can go ahead and hit the cycle start button to start the tool change. Now we have an empty pocket pulled up in the spindle. We're going to go ahead and load our tool. Tool 2 today is going to be a 2-inch face mill. To go ahead and load a tool, we're going to use this button on the spindle face. Now what this button does is actuates the drawbar. The drawbar inside of this spindle is going to release, grab this pull stud, and pull the tool into the machine. We need to verify that this slot and this slot are aligned with these two keyways on the spindle bearing. Now to manually load the tool, I hold the tool in my left hand, keeping my hands away from this top part. I want to hold down here. Stay away anything after the collar. I'm going to depress my button, line the tool up, and let go. And it's going to load the tool into the machine. Now that the tool is loaded in the spindle, we're going to go ahead and touch the tool off on our reference block. The reference block will come in a box like this. And what it is a dial indicator with a little button on top that moves to a 0 or a set point when we get the tool to it. We place this block on the bed of the machine. We take an insert, in this case with the face mill, we're going to pick one of 4 inserts. And we're going to touch the insert to this face here and run it to our 0 on the dial right here. Now it's important that we don't touch off on the center of this face mill. We have to set off on an insert because the center is lower than the insert. Now to touch off, we'll go to our handle jog button. We'll hit our 10 thousandths. I'm going to select my x-axis and I'm going to move about in the center of that block, and then I'm going to select my z-axis and jog minus till I get pretty close. And then once I'm within about an inch, I'm going to select this 1 thousandths button. What that does is slows the machine down so that I don't accidentally run into my setup block. From there, I'm going to go ahead and lower my insert down to my block until I see it hit my 0. Now that we're on our 0 point, I need to save my tool length in the machine control. Now, Haas automatically highlights the active tool in the control in orange. You can also see that next to tool 2 it says spindle. That means that is the active tool in the spindle. We're going to highlight our length geometry, which is right here in orange, and then we need to save our machine position, which is the machine position from home down to the tool presetter, in this box. To do that, I'm going to go ahead and hit my tool offset measure button right here. And when I hit this button, my machine position in Z is going to match what's in the offset box. Now we need to go ahead and establish this diameter geometry. If this tool was to use cutter compensation, it would need that information. This is a 2-inch face mill, so I'm going to type in 2.0, and I'm going to go ahead and hit F1 set value in this top left corner. When I hit that, it's going to ask me, are you sure you want to change this value? We're going to go ahead and hit yes, and it's going to change my diameter geometry to 2 inches. Now that the face mill's set up, we're going to go ahead and set up our 1/2 inch end mill in the machine. To do so, I'm going to shut my door, and I'm going to lift that tool up to the home position. I don't want to tool change with it down there. It could rapid XY and hit something. We don't want to do that. So I'm going to go back into my MDI tab, and I'm going to hit Z G28. And when I hit Z-axis into this box here and hit G28, what that's doing is telling it to home 1 axis at a time. I don't need to do all of them, I just need to get Z out of the way. Now that our tool's picked up, we're going to go ahead and get rid of this T2M6 in the box. So I'll hit that Erase Program button we talked about earlier, and I'm going to type in T3M6, enter, verify it's correct, and then go ahead and hit cycle start. Now that the empty pot's pulled up, we're going to open the door. I'm going to verify where my 2 tabs are, press my button, load the tool into the spindle, go ahead and select handle jog. Now, one thing to note, when you select handle jog, it's automatically going to pull up your offset screen here. I'm going to go ahead and jog over to my tool presetter. and I'm going to run down to that Z0. Once I'm at Z0, I verify that I'm on my tool length. We're not, we're on geometry at the moment, so we'll cursor over to our tool length and then hit that tool offset measure button. And then verify that our machine position matches our tool offset. From there, we make sure our diameter geometry is also set to a 1/2 inch. In this case, it is already set to a 1/2 inch. Now I'll go ahead and load my last tool and repeat the last process. Load the tool, touch it off, send it home. Now that our tools are loaded and set up, we need to set up our workpiece and establish our work coordinate. I'm going to go ahead and call up my edge finder, so back into MDI, hit erase program, grab tool 1, M6, enter, and cycle start. Now, standard on our milling machines, tool 1 is always the edge finder. The only exception of this is our A-trump mill that is tool 16 for our edge finder. Now we're going to go ahead and open the door and get our part loaded into the machine. Today we're running the Turner's Cube. We're going to be using our tallest parallels we have, so we have as much clearance in the Z as possible. So I'm going to go ahead and place my parallels in the machine. Grab my vise handle. Snug my part down. And give it a hit with the hammer to set the parallels. Now that the part's loaded in the machine, we're going to go ahead and establish those work offsets. To do that, I'm going to shut the door and I'm going to activate the spindle or turn on the spindle. So I'm going to go M3, S750 and hit enter. Then I'm going to hit cycle start and that's going to turn on my spindle. Now on the Haas machines, 750 RPM is as fast as they can run with the door open. Anything over that and it's going to throw a fault and the machine's not going to work. Now with the spindle on and our edge finder turning, I'm going to go ahead and establish our X and our Y work offsets. To do that, I'm going to hit my handle jog screen. And then I'm going to go up here to this position screen at the top under display. There's 5 tabs. To cover these briefly, work is our XY location from our last work offset called. Distance to go is the distance from where the machine is now to where the next command is and the distance to get there. We'll cover that when we start running the program. Machine is the machine position from home. So when the machine's at home and it moves to whatever location you have it at, that is the distance from home. The operator tab is the same as a digital readout on a manual machine. It doesn't save our work coordinates in the control, it just helps us find them or reference them. So I'm going to use this to establish my work offset on the machine. So right now we're highlighted in X. I'm going to go ahead and select my 10 thousandths jog. And I'm going to move this in and I'm going to touch this X-axis here on the left side of my part. So I'm going to move in, I'm going to grab Y-axis, drop my Z, make a little adjustment, and now that I'm close to the part, I want to switch to that thousandths tab here. We don't want to run into something, we're taking our time. Now I'm going to go ahead and move this X-axis until I see the edge finder kick. And there we have a kick. Now, This is not zeroed out. To zero this out, I select this origin tab down here on the control. When I do that, my x-axis zeros. Now, the reason I use this operator tab to help set up is it's a good reference for me. If I touch off and I miss a click, it's really hard to notice that. But in the operator tab, if I zero when I touch my part, and then I go to move my edge finder or my material offset, I can see if I accidentally missed a click somewhere and I have too much on one side or too little on the other side. So I went ahead and zeroed. I'm going to pick up my z-axis in the machine, and we're going to move over an x 100 thousandths. So I'm going to select this 100 thousandths button here, and we're going to move this over 100 thousandths. Now what that does is position the edge finder over the edge of the stock. It doesn't take into account our work offset yet, or our leftover material from the stock to the actual part dimension. We need to establish how much extra stock we have to remove from each side of the part. And in this case, we have a 1-inch cube, or 1-inch square stock, and an 875 dimension part. We have 125 thousandths of total material that we can divide by 2 and split on each side of the part. In this case, that's 62 thousandths and 5/10. So I'm going to go ahead, I've already moved my 100 thousandths for the edge finder. Now I'm going to add an additional 62 thousandths in X positive, and what that's going to do is distribute equal material on both sides of the part. Now that I've located my X, I need to go ahead and reference it on my control. So I'm going to hit this origin button and 0x in my operator. Now remember, that does not save it to the control, it is only a reference for you right now. We're then going to select our y-axis, I'm going to select thousandths, and I'm going to move this to the back edge of the part. And then I'll lower down in Z, select my y-axis again, and I'm going to jog into the back of this until I see that edge finder kick. Okay, our edge finder kicked. I'll go ahead and hit origin to set it on the edge of the part. Now I'm going to pick it up in Z until I clear my part, select my y-axis, my 100 thousandths button, and I need to move this towards the minus end of the table, 100 thousandths for my edge finder. So I'm going to select -1. I can see that I moved -1. I'm then going to do my stock offset, so I'm going to add 62 to this, and I'm going to go ahead and zero that. Now my X and my Y are referenced, they are not saved in the control. To save them in the control, we select our offset button, and then we're going to go to the top of the screen and select work offset. From there, I'm going to scroll down on the screen until I get to G54, X, and Y. Now that I'm highlighted on G54X, I need to save the machine position here at the bottom to this box and this box. To do that, I'm going to hit this part 0 set function. I'm going to hit it for X and again for Y. And then I'm going to verify that my X-axis, which is -12.2390, matches the machine position, -12.2390, and my y-axis, -3.2480, matches the machine position of -3.2480. They both do. To find our Z offset, we don't have probes on these machines. We reference the Z manually with our edge finder. So what I'll do is turn off my spindle with this spindle stop button. To reference my Z offset, I'm going to go ahead and grab a piece of paper, and I'm going to touch my edge finder to the top of the part in thousandths. Do not go 10 thousandths, you'll ruin the edge finder. We'll go thousandths, Z, and we'll walk this in until we get nice and close. Take our piece of paper, stick it underneath, and wiggle this back and forth and bring Z down at the same time until we feel friction. Okay, there I've got just light friction. I can still drag the paper a little, but we're in contact with the part. From there, I'm going to go back into my position screen and zero out my Z operator. hit the origin button, and it's 0. Now that we're touched off on the top of the part and our Z is zeroed, I need to tell the machine what the difference is from where the top of the part is to where my tools are referenced to. It needs to know that measurement. To do that, I'm going to pick my Z-axis up off of my part, pick it up, grab my X, speed up to 10 thousandths, and I'm going to go over to my tool presetter, and I'm going to run this edge finder to 0. Now that it's on 0, I have a measurement on the screen, and it is 3.5240. That number is the distance from where the tools are set to the top of the part. The machine takes this number and subtracts it from its machine home position to establish a Z offset. So I'm going to save this number by going into Offsets, highlighting my Z axis, and I'm going to type in the number displayed in the bottom right, 3.5240. And then I'll go ahead and hit F1 set value, not enter or add value, F1 set. The difference between these two, F1 sets it to a new value, enter will add it to the previous one, so you'll double basically the height of your work offset, which is what we don't want. So I'll go ahead and hit F1 set, and yes. Now, this number in the operator screen, bottom right-hand corner for Z, is displayed as a negative. That's because I went from the top of the part, zeroed, and went down. So it's going to display as a negative number. We never want to type our Z offset as a negative. What you're doing if you do that is essentially telling it your part is located below the tool presetter. So you're going to try and mill something down in here, and it's going to go through your part and your vise to get there. We don't want to do that. Always type that number in as a positive. Now that we have this number typed in, we're going to go ahead and lower that number by 20 thousandths. And what that's going to do is drop our work offset into the stock instead of on top of the stock, so that we get a nice clean cleanup with our face mill. To do that, I'm going to type in minus 0.02. And rather than use set value, I want to add it. So I'm going to go ahead and hit enter, and that subtracted 20 thousandths from my work offset. Okay, now that our tools are loaded and our work offsets are done, we need to go ahead and load a program. So you'll get your USB, locate the USB port on the right-hand side of the control, plug in your USB. I'm going to go ahead and select List Program here. What that's going to do is it's going to pull up every program in the control. We want to cursor all the way to the top, to this box, and then over to USB. Now that we have our USB highlighted, it's showing all of the active programs on that USB. I'm going to go ahead and select my Turner's cube. So I'm highlighted. Now I need to select it. Now if you look on the right-hand side of the screen, it says mark is enter. So I'm going to mark it with enter, and then it says F2 to copy. So I'm going to hit F2 to copy, and then it's going to pull up this page here, copy to. We want to copy it to the memory. So I'm going to go ahead and hit enter on memory, and then this blank line right here is a blank spot in the directory. So I'm going to go ahead and hit enter. Now if it pulls up this file or folder already exists, that means your program number is the same as a program number already in the control. We can override that by simply hitting yes. Now once our program's loaded, we can verify that it loaded by hitting this Edit tab here. Now in the Edit tab, you can go in and you can verify tool numbers, you can verify that you've got all the codes you need, like G54, do my G43 and my H numbers match my tool number? Anything of that sort. If you forget a decimal on a feed rate, which happens all the time, you can highlight that feed rate, and I can say, okay, F28 with no decimal. I'm going to go ahead and type F28 with a decimal and select the Alter tab. And that's going to change that to F28 with a decimal now. Now at the top it'll say not saved because I've made a change and I haven't saved it. If I look at the bottom of the screen, it's going to say memory, save and load. If I hit memory, it'll go ahead and save it and load it. Now that our program is loaded, we need to verify it in graphics. To do that, I'm going to select my memory tab as if I'm ready to run, and then I'm going to select graphics, and I'm going to hit cycle start. Now on the screen you can see it displayed all of our wireframe or cut geometry, and it ran all the way through without an error. If it throws an error, down here in the bottom of the screen in big red letters is going to be that message. Cutter comp interference, T and H not matched, something of that sort. If you can't fix that, go ahead and grab an instructor and we'll help you fix it. Now that we're ready to run the program, there's a couple of precautionary steps we take beforehand. We'll select position, go to our distance to go, which we'll talk about in just a second, verify that we're on single block, and 50% before we start running. Now, when it's in 50%, that is acceptable for any XY move above the part. The second we come down in the Z, I want 5% on rapids anytime we're proofing a new program. It's a lot easier to stop a crash if the machine's moving slowly versus full speed or even 50%. Now that we're ready, I'm going to go ahead and start hitting single block, and I'm going to work up to this G54, G00 line. It's not going to tool change because tool 2 is already active in the spindle. But now that I'm on this G54, G00, XY location, you can see that it's highlighted in gray. Whatever's highlighted in gray is what it's going to do next. I'm going to go ahead and I'm going to hit cycle start and then immediately hit cycle stop. So I'm going to go cycle start, cycle stop. Now the reason I do that is to show you these numbers in the distance to go. What distance to go is where the machine is to the coordinate you've commanded. It's the distance between that. If this ever said something that I didn't agree with, I'm going to stop and see if my numbers are correct or incorrect. I'm going to go ahead and let it finish out this position move. My next move is G43, height of tool 2 to Z 1 inch. Now that I'm going to do a Z move, I'm going to go ahead and select 5% rapid. And then I'm going to do the same thing, one finger on green, one on red, and I'm going to let this come down in the Z. Tool's coming down, nice and slow, we're taking our time. Okay, our next move is M3 S4000. We're going to turn our spindle on to 4,000 RPM. Spindle's on. Now we're going to rapid to Z.1, again still on 5% rapid. So we're going to come down. Now, if I saw something in here I didn't agree with, like if it was going to go Z minus 2 inches, I would stop and fix that number. We're at Z.1, we go ahead and drop to Z0. You can see it's there. The next line I can see it's going to move X 3.4 inches positive. That's acceptable. I'm going to go ahead and let it take the first cut across the top of this part. Next move is turn off spindle, turn off coolant, Z positive 1.1 inches. And then we're going to go ahead and tool change M6 to tool 3. I'm going to go ahead and select 50% rapid. Now we have our half-inch end mill. First move on the screen is an XY position move in G00 rapid. I'm going to go ahead and let it do that. Next move is height offset to 1 inch. Select 5% now that we're getting close. That looks acceptable. We're going to go ahead and turn on our spindle to 4,000 RPM. Blank line. We're going to go to Z.1, so we're going to travel 900 thousandths to get there. That's acceptable. I can see I've got that much room. 0.5, nice and easy. Our next move is down to Z depth, so it's going to go 985 thousandths to get to Z minus 885 thousandths. It's going to get there at a feed rate of 15 inches a minute. It's coming down. We watch our vise. We made it. Next move is it's going to activate cutter comp, shift to Y positive 10 thousandths with a D value of 3. We have tool 3. So now we'll see that Y offset shift. And we're now in position ready to cut in our X offset. So we're going to go ahead and let that go. I'm still in single block. We have an active feed rate, a couple of things to look at, and go. And then we're going to move in Y. X. Y. X. Y. Now what I'm watching for is anything that just doesn't make sense. I'm looking for a Z move that shouldn't be there. I'm looking for numbers that are missing a decimal, anything of that sort. I'm looking several lines ahead before I run it as well. Okay, so we've completed our contour. We're going to go ahead and cancel our cutter compensation and move away from the part X minus 0.5 to Y 0.5. That's critical, otherwise our tool is going to gouge our workpiece. And there we turn off our spindle, turn off our coolant. We pick the tool up. And we're going to tool change. Now we're on our last process for this program. We're doing a G54, G00, XY position. Go ahead and let it do that. And then the next thing we're going to do is take our tool, read our height offset. I'm going to slow down to 5%. And we're going to drop down to 0.1 above the part. We watch that, walk it in. Boom, we're there. From there we're going to turn on our spindle. Got a blank line. And then G01, Z to 0, that's 100 thou, that is acceptable. We're now on our part. And from here it's going to start its helix interpolation into the material. Okay, spindle stopped. Now we're going to have a G53, X negative 16, Y 0. This is a position move. All right, now that our part's done, we'll go ahead and take it out of the vise. Blow it off. Set it aside. Hang up our handle. Remove parallels. And from here we start our cleanup procedure. So I'm going to turn off the coolant on the side of the spindle, hit my coolant on button, grab my wash hose, and wash the machine down. getting the T-slots, washing the inside of the vise. Sometimes I like to hide behind the door so that I don't get all wet. Put that away, turn off our coolant, grab our air gun, blow off the standing water. We don't want to blow off piles of chips. That's not good for these machines. We want to just get rid of the standing water. From there, we'll start unloading all of our tools. And then do this checklist on the side of the machine. Every machine has this clipboard. You're going to wash it down. Are the tools removed? Is the spindle empty? Are the hand tools wiped down and put away? Is the floor swept or mopped if necessary? And is the cart clean and put away? And then you'll get an instructor initial. The final step is go ahead and hit power off and turn the machine off.